Welcome to Maths for A channel, a past question on pure mathematics from Sri Lankan A level paper, past paper. Let UR equal 1 over R time R plus 1 time R plus 3 time R plus 4, and VR equal 1 over R time R plus 1 time R plus 2. R is an element of a positive integer. Show that VR minus R plus 2 equals 6 UR. So let's prove that first. UR is given 1 over R time R plus 1 time R plus 3 time R plus 4. And the VR is given 1 over R time R plus 1 time R plus 2. What we need to prove that VR minus VR plus 1 is equal 6 UR. So let's start with VR. Find VR, which we have been given 1 over R plus R time R plus 1 time R plus 2, VR plus 2. So substitute R plus 2 instead of R. So R plus 2 times R plus 2 plus 1 is R plus 3. R plus 2 plus 2 is R plus 4. So VR plus 2. Now we are this left-hand side. Just take the left-hand side of the proving equation. VR minus VR plus 2. Simply, we know them both. And it's 1 over R times R plus 1 times R plus 2. 1 over R plus 2, R plus 3, R plus 4. And take LCM. R plus 1, R plus 2, R plus 3, R plus 4. And of course, we have R plus 1, R plus 2 here. And what we haven't, R plus 3, R plus 4, R plus 3, R plus 4 minus, again, R plus 2, R plus 3, R plus 4 there. So all we haven't, R times R plus 1. Right, expanded the numerator. R numerator become R squared plus 7R plus R, 4 times 3 is 12. Minus R squared minus R. R squared cancel out. 7R minus R is 6R plus 12. So 6R plus 12, the denominator is still the same. And if you take 6 out, then R plus 2. And R plus 2 cancel out the denominator. So the numerator 6, the denominator R plus 1, R plus 3, and R plus 4. And what we need to prove that 6, the U already given is 1 over R times R plus 1 times R plus 3 times plus 4, and 6 there. So that is 6 times UR. So that part is done. So just 6 UR equal VR minus VR plus 2. We're going to use that the equation that we proved. So keep that UR on the left-hand side, and then VR minus VR2. Just simply starting from R equal 1, R equal 2, and so on. R equals 2, and so on. U1, R6 U1 equal R1 minus R is 1, so V3. And then 6R2 is V2 minus V4. 6U3 equal V3 minus V5. And if you could continue and up to UN. So say, for example, 6UN minus 4 and Vn minus 4 and Vn minus 2. U6UN minus 3, Vn minus 3 minus Vn minus 1. 6UN2, UN minus 2 is Vn minus 2 minus Vn. And 6UN minus 1 equal Vn minus 1 minus n plus 1, Vn plus 1. 6UN equal Vn minus Vn plus 2. If you see that, if you add the right-hand side and left-hand side, the right-hand side, it's U1, U2, U1 plus U2 plus U3 plus, so it's the right-hand side, 6 times U1 plus U2 plus, and so on, up to UN. That is this. 6 sigma or sum of R1 plus R1 R equal 1 to n and un. And this side, if you look at it, say the third part, this V3 cancel out, positive V3, negative V3, positive V5, negative V5, and so on. So it's two components on the left-hand side left, and the n, the two components left. So V1 plus V2 minus Vn plus 1 minus Vn plus 2. So V1, so R equal 1, R equal 1, V1 equal 1 over 1 time 2 time 3 because of R time R plus 1 time R plus 2. So that is 1 over 6. And then V2 is substitute R equal 2. And 1 over 2 times 3 times 4, that is 24. And Vn plus 1, again, R equal n plus 1. As 1 over n plus 1, n plus 2, n plus 3, and then Vn plus 2, 1 over n plus 2, n plus 3, n plus 4. So simply 6. So sigma, or sum of R1 to n, UR equal, this side, left-hand side, right-hand side, 1 over 6 plus 1 over 24, and plus, minus 1 over n plus 1, n plus 2, n plus 3, minus 1 over n plus 2, n plus 3, n plus 4. So this is 24 LCM. Then is 6 times 4. Yeah, 4 plus 1 is 5. And minus LCM here, n plus 1, n plus 2, n plus 3, n plus 4. The n plus 1, n plus 2, n plus 3 there, only we haven't got n plus 4. So n plus 4 plus, and the next part is n plus 1 not there, so therefore n plus 1. So sigma or sum of R1 to n, you are, the left-hand side is still the same, 5 over 144 because a cross multiplication of 6. So it's just, this is this one, 24 times 6. And here 6 as well. Yes, cross multiplication. The nominator, n plus 4, n plus 1, that is 2n plus 5, and divided by 6 times n plus 1, n plus 2, n plus 3, n plus 4. That is what we have been asked to prove. Yes. Sigma 1 to n, ui equal 5 over 144 minus 2n plus 5, 6 times n plus 1, n plus 2, n plus 3, n plus 4. Right, now, the second part, next part, WR equal U 2R minus 1 plus 2 U 2R is given. And deduce that sigma or sum of R1 to n, WR equal 5 over 144 minus 4n plus 5 divided by 24 times n plus 1, n plus 2, 2n plus 1, 2n plus 3. Okay, let's do that. So this is right. Okay, this one is given. This one is given. W is that. So W1 is simply U1, U2. So if you, so R equal 1. So W1 equal 2 minus 1, 2 times 1 minus 1 is 2 U1, and then 2. Then R equal 2, W2, 2 times 2 minus 1 is 3, plus 2 times 2 is 4. And 3 is 5 and 6. 4 is 7 and 8. So just and so on up to Wn, R equal n, U 2n minus 1 plus U 2n. If you look at that right-hand side, left-hand side, is sum of or sigma R1 to n, or sum of WR R1 to n. And this side, if you look at it, R1, R2, R3, U1, U2, U3, U4, U5, U6. So it just simply, it's U1 plus U2 plus U3 if you add them together, and so on. So just right-hand side, sigma R1 to 2n, because of it comes to 2n. So not n, 2n. So R1 to 2n, you are simple as that. So instead of n, it's 2n. That's it. The left hand side, keep it like that, and nothing changed. All you do is just substitute. We already proved this this one. So we know the sigma UR are 1 to 2n. 1 to 2n. We should in this side is n. This side is 2n. Yeah. Simply R equal to n. So 5 over 144, no change. Instead of n, 2n, 2 times n, so 2 times 2n plus 5 over 2 times, so 2n plus 1, 2n plus 2, 2n plus 3, 2n plus 4. And the nominator, still 5 over 144, still keep the same. And the denominator, the second part, the denominator, 4n plus 5, 4n plus 5, and 24. I put it, and it just tell you, I took 2 out of here, I took 2 out of here. So 2 times 2, 4, 4 times 6 is 24. So this is 2n plus 1, that is here. And the next one is 2n plus 2, but I took 2 out, so n plus 1, that is here. And 2n plus 3, that is here. And 2n plus 4, I took 2 out, there, so n plus 2, that is here. So all here, so it's what we have. The sigma R1 to n WR equal 5 over 144 minus 4n plus 5 divided by 24, n plus 1, n plus 2, 2n plus 1, 2n plus 3. That is what we have to prove, and we have yes, 4n plus 5 over, so 5 over 144 minus 4n plus 5 over 24 times n plus 1, n plus 2, 2n plus 1, 2n plus 3. That's done. Hence, show that the infinite series is WR, so 1 to infinity, is convergent, and find its sum, its value. Okay, we know this bit, this one, is the WR R1 to n. Right, so now R1 to infinity, so n become infinity, whether 2n or whatever, is infinity now. So 5 over 144 is the same. The infinity, n tends to infinity, fn. So I just put it fn. This part is fn. The whole thing fn. So if n tends to infinity, fn tends to 0 because of foreign is a linear function. If you could take out one linear function, but it's still got the n to the power 3 or third polynomial, which is infinity, and 1 over infinity is 0. So that's 0. So what we have is R from 1 to infinity WR equal 5 over 144. So obviously we have the finite value. Therefore, the R from 1 to infinity WR is convergent, and its value is 5 over 144. Thank you. Please subscribe the channel and share the contents with your friends and other students. Thank you.